Hi students, good morning everyone. Now we are going to talk about Unit 3 Periodic Classification of Elements. There are millions of chemical compounds existing in nature with different composition and properties, formed from less than 100 naturally occurring elements. In 1789, Lavoisier from France, he scientist, published the first list of chemical elements containing 23 elements. After several experimental investigations, Lavoisier classified the substance into four groups of elements, namely acid making elements, gas like elements, metallic elements, and earthly elements. First one, acid making elements. This is Lavoisier table. Acid making elements sulfur, phosphorus, carbon, and gas like elements light, heat, oxygen, nitrogen, and hydrogen. And another one, metallic elements cobalt, mercury, tin, cobalt, nickel, iron, cobalt, lead, silver, zinc, manganese, tungsten, and platinum. Earthly elements lime, calcium oxide, magnesium oxide, and barium sulfate, aluminum oxide, and silicon dioxide. This is Lavoisier table. Next one, Daubrunner triads. In 1817, J.W. Daubrunner classified some elements such as chlorine, bromine, and iodine with similar chemical properties into the group of three elements called as triads. In triads, the atomic weight of the middle element nearly equal to the arithmetic mean of the atomic weights of the remaining two elements. For example, Dominator's table. For example, lithium, sodium, potassium. Lithium atomic number 7. Potassium atomic number 39. Average atomic weight of these middle elements 7 plus 39 divided by 2 equal to 23. The middle atomic weight of the middle element sodium 23. See, Dobner triads and Newland's actives. And arranging the elements in the increasing order of atomic weights. He observed that the property of every 8 elements are similar to the property of the first element. The law holds good for lighter elements up to calcium. Actives lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Lithium to sodium, sodium to potassium, beryllium to magnesium, magnesium to calcium, boron to aluminum. Okay. Just periodic table. It's a very important one. Just one, periodic table. First one, what is the modern periodic law? The physical and chemical properties of the elements or periodic function of their atomic numbers. This is modern periodic law. First one, periodic table. This is S black elements. This is B black elements. This is D black elements. This is F black elements. Okay. S black element general formula, general electronic configuration formula NS2 1 NS 1 to 2. B black elements general formula. Listen, wait. First one, this is S black, this is B black, this is D black, this is F black. This is 4 black elements. First one, the S black elements. Like elements of group 1 and group 2. Group 1 and group 2 are called S black elements. Since the last valence electron enters the ns orbital. Listen, the last electrons enter the ns orbital. The group 1 elements are called alkali metals, while the group 2 elements are called alkaline earth metals. There are soft metals at passing low melting and boiling points and low ionization enthalpies. There are highly reactive and form ionic compounds. They are highly electropositive in nature, and most of the elements imparts color to the flame. We will study the properties of these groups elements in detail in subsequent chapters. Next one, B black elements. The elements of groups 13 to 18 are called B black elements. Next one, B black elements. The elements of groups 13 to 18. Listen, 13 to 18 are called B black elements, are representative elements and have general electronic configuration ns2np126. This is ns2 122 ns2np126. The elements groups 16 and 17 are called chalcogens and halogens respectively. The elements of 18 groups contain completely filled valence subshell electronic configuration ns2 np6 and called and, and are called inert gases or noble gases. The elements of B black have high negative elements gain enthalpies. The ionization energies are higher than that of X black elements. The form of mostly covalent compounds and shows more than one oxygen state in compounds. Next one, D black elements. The elements of the groups 3 to 12 are called D black elements or transition elements with general valence shell electronic configuration ns 1 to 2 and n minus 1 d power 1 to 10. These elements also show more than one action state and from ionic covalent and coordination compounds. They can form interstate compounds and alloys which also act as catalyzed. These elements have high melting points and are good conductor and heat and electricity. And another one, F black elements. F black elements, lanthanides and actinides. The lanthanides and the actinides are called F black elements. These elements are metallic in nature and have high melting point. Their compounds are mostly colored. These elements also show variable action states. General and outer electronic combination of elements in groups. Group 1 and 2 S black elements, ns1 and ns2 general electronic configuration, and group 13 to 16 18 B black elements, ns2 np126 general formula, and group 3 to 13 D black elements, ns2 n-1 t power 1 to 10, and last one F black elements, lanthanides and actinides. Lanthanides general formula 4f 1 to 14 d power 0 to 1 6x2. Actinides 5f 0 to 14 6d 0 power 0 to 2 7s2. And nomenclature of elements with atomic number greater than 100. Usually, when a new element is discovered, the discoverer suggests a name following IUPAC guidelines, which will be approved after a public opinion. In the meantime, the new element will be called by a temporary name coined using the following IUPAC rules until the IUPAC recognizes the new name. Rule number 1. The name was derived directly from the atomic number of the new element using the following numerical rules. Double notation for IUPAC nomenclature of elements. Digit 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Root 0 to 0 means nil, 1 means and, 2 means by, 3 means try, 4 means quad, 5 means bent, 6 means hex, 7 means set, 8 means act, 9 means n. Abbreviation 0 n, 1 u, 2 b, 3 t, 4 q, 5 p, 6 h, 7 s, 8 o, 9 e. Rule number 2. The numerical roots corresponding to the atomic number are put together and IUM is added as suffix. Rule number 3. The final n of enn is omitted when it is written before nil. N plus nil, nil. NIL. Similarly, the final I or I of by and try is omitted when it is written before IUM. By plus IUM. By trium. Okay. Rule number 4. the symbol of the new element is derived from the first letter of the numerical roots. For example, 1. For example, atomic number 101. 1. First one 1. 1 root han un. 0 root nil nil. Again 1 root un and nil and last suffix add to suffix ium. Anilinium. Temporal symbol u n u. Name of the element Mendelevium and symbol md. The electronic combination of elements in a periodic table. It's an alpha method. Oneness, 2. The higher energy of the orbital, higher energy the electronic configuration orbital. Listen, oneness. First one oneness, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, etc. Okay, this is electron converse elements in orbital or high energy of the orbitals. This one atomic radius. Periodic terms in properties. The periodic terms in the following properties of elements: atomic radius, ionic radius, ionization enthalpy, electron gain enthalpy, and electron negativity. First one, atomic radius. Atomic radius of an atom is defined as the distance between the center of the nucleus and its outermost shell containing the valence electron. Next one, covalent radius. 3 types of atomic radius: covalent radius, metallic radius, and last one, van der Waals radius. See, first one, covalent radius. It is one of the internuclear distance between two identical atoms linked together by a single covalent bond. Internuclear distance can be determined by using X-ray diffraction studies. This is homonuclear covalent bond because DClCl is a homonuclear bond. So, okay. For example, DCl is a diameter Cl is equal to Cl with radius of chlorine plus radius of chlorine to 2 radius of chlorine. Answer 0.99 angstrom. Let us calculate the coordination radius of hydrogen using the experimental DHCl value 1.28 angstrom and the radius of chlorine is 0.99 angstrom. Is Pauling scale the alternative of chlorine and hydrogen are 3 and 2.0 respectively. This is heteronuclear bond. This is heteronuclear global bond. D of H and D of Cl, so various atoms. RH plus RCl, this is finally answer RH equal to 0.371 angstrom. Next one, metallic radius. It is defined as one of the distance between two adjacent metal atoms in the closely packed metallic crystal lattice. For example, the distance between the adjacent copper atoms in solid copper 2.56 angstrom, and therefore the metallic radius of copper is 2.56 divided by 2. And the effective nuclear charge. Listen, in addition to the electrostatic forces of attraction between the nucleus and the electrons, there exist repulsive forces among the electrons. The repulsive force between the inner shell electrons and the valence shell electrons lead to the decrease in electrostatic attractive forces acting on the valence electrons by the nucleus. Thus, the inner shell electron acts as a shield between the nucleus and the valence electrons. The effect is called shielding effect. The net nuclear charge experienced by valence electrons in the outermost shell is called the effective nuclear charge. It is approximated by the below mentioned coordinate ZEF equal to Z minus X. ZEF equal to effective nuclear charge, Z equal to atomic number, S is the straining constant. This is latest rule. First one, listen. This is, for example, let us explain the calculation of effective nuclear charge on 4s electron and 3d electron is scandium. The electronic configuration of scandium 1s2, 2s2, 2p6, 3s2, 3p6 and 3d2, 4s2, 3d1. Okay. 4s orbital. 4s means n, 3s, 3p, 3d gives n minus 1 and n minus 2 and n minus 3. Rules for n equal to values 0.35, n minus 1 0.85 value and n minus 2 others 1. Therefore total value 18. Scandium atomic number 21. 21 minus 18. 21 minus 18. Therefore 3. ZEF value 3. Shielding effect for inner cell translators rule n equal 0.35 or 0.34 yes sir. And n minus 1 0.85 and n minus 1. The calculation of effective nuclear charge on 3d electron. Listen carefully. 3d electron is d orbital, n equal to 0.35 value, n minus 1 equal to 1.1 value, total value 18 and final value 3. What is the effective nuclear charge? The net nuclear charge experienced by valence electron in the outermost shell is called the effective nuclear charge. Okay. Ionization energy. Next one, ionization energy. It is defined as the maximum amount of energy required to remove the most loosely bound electron from the valence shell of the isolated neutral gaseous atom in its ground state. This is expressed in kilojoule mole inverse or in electron volts. It's a very important question. Electronic configuration of nitrogen and electronic configuration of oxygen. 1s2 7, 1s2 2s2 2p3 oxygen, 1s2 2s2 2p4. The nitrogen is a half filled, oxygen is a not half filled or not full filled. Listen, nitrogen is a half filled electronic configuration which is much more stable than incomplete p orbital of oxygen. which would need to give our one of its electrons to attain the stability of nitrogen. Hence, nitrogen would require more ionization energy to remove an electron from its outer shell than oxygen. To electron affinity, it is defined as the amount of energy released when an electron is added to the valence shell of an isolated neutral gaseous atom in this ground state. To form its anion, it is expressed in kilojoule mole inverse. Electronegativity, it is defined as the relative tendency of the element present in a covalently bonded molecule to attack the shared pair of atoms towards itself. So diagonal relationship. Similarly, in properties existing between the diagonally placed element is called diagonal relationship. Thank you, students. Book by questions. Important question. Please write the test. Define modern periodic law and what is an effective nuclear charge. Define electronegativity. Define shielding effect. Explain the following method of the determinants of ionic radius and explain the diagonal relationship. Explain the following appropriate reasons. First one, ionization potential of N is greater than that of oxygen. Okay. Thank you. God bless you, my dear students.